All right, ladies and gentlemen, welcome to a northern Minnesota acid peatland. We are here today with a couple of folks. Yours truly, Andy, and Brad Jones is an instructor at Tasca Community College and a professional forester. When Brad worked for Tasca County Land Department, this was part of his area? Part of his area. So we're just kind of giving you a panoramic view of northern Minnesota bog, or in Minnesota DNR parlance, an acid peatland. We're going to take a look at a couple plants today, a couple trees, some of the lower shrubs, but also talk about how it was formed, because much of the soils and landforms help determine moisture, fertility, and then what species can grow on this site. Okay, Brad, why don't we come out and take a look. First of all, we probably want to notice the, well, let's do the ones in the back first. Way in the back, we can see black spruce, quite tall. And if you look, you've got these knobs at the top of those trees. And from my understanding, this is a function of squirrels cutting the cones, which breaks up the terminal leader, and so you've got this profusion of laterals. And well, we also see them in the foreground. There's one right here, a couple of them right in front of us. The other thing we want to see today and talk about are tamarack. And you probably remember, or will know soon enough, that tamarack drops its needles every fall, turns a bright yellow. After all the hardwoods have had their splendor and color, it's time for the tamaracks to light up the bogs. So why do we find black spruce and tamarack on a site like this? How is this site different from anything else we've seen? What are we thinking? Bog should be what?
Wet.
Wet. Absolutely. Wet. And along with that moisture, a ton of moisture, but we don't see any other species besides really black spruce and tamarack on this bog, at least tree species, because there's really low fertility here. So we've got a very, very wet site, but a very infertile site. So why is this wet and infertile?
Most of the nutrients that are coming into this site really occur here as a result of rainfall or dustfall. There's very little additions. The soil is not decomposing. In your upland site, I like to think of soil particles over time, essentially just shedding off nutrients as they decay. In the bog, we don't see that. The bog does not decay. It just continually adds mass from the bottom up. It adds that organic matter, and will continue to increase in size here, or increase in height. So no real major decomposition of the soil matrix, of the soil particles, in this case all organic material.
And what else? How did we get to a bog condition? I mean, why do we have a bog here, and just another 200 meters down the road we've got red pine and jack pine?
Okay, so this area that we're standing in, we're standing about, I'm just going to guess, about 40 miles north of Aiken, Minnesota. And if you take a look at a map at this point, and you'll see that we're approximately at 40 miles north of Aiken. We are on the edge, on the northern edge of a large glacial lake formed about 10,000 years ago when the ice melted. And so as it melted out, the sand was deposited along the edges of the lake. And so where we are is just like going to the beach, sit on the sand beaches. We are essentially on those sand beaches of Glacial Lake Aiken, Glacial Lake Upham, were connected at one time. So the lake was 40 or so miles north to south, and perhaps a bit more, and width-wise maybe about 20 miles or 15 or 20 miles wide. So quite a large glacial lake. On the edges here we have these essentially sand dunes or sand beaches. And in between the dunes we have large depressions. And as the regional water table established itself about 4,000 or 5,000 years ago, the peat moss began to take hold. And so the peat moss has been carrying the water table up with it as it continued to rise. So you see the vast majority of the vegetation here.
Sphagnum.
Sphagnum.
Look at that. Here, you want a close-up? So sphagnum's here, and this stuff grabs the moisture from the water table, and if we dig down, there's two things we notice. One, I think this should be about, there's lots of moisture that I can do this with that we don't get in an upland site or in in even a mesic hardwood site. The other thing is, it's cold.
Yeah.
I mean, it's just, this is very comfortable right now. This could be fun.
On a day where it's almost 80 degrees outside.
Yeah. Okay, so it's a little dirty, but I'll forgive it that. That's why we have dark jeans. So we've got this moisture that the sphagnum holds, and it also makes it cool, but it does something else too, doesn't it?
Yeah, so sphagnum is, so like a sponge, you can kind of think of it like a sponge. And it has a high affinity to some of the cations, so it soaks them up, it draws them in. If some calcium falls in here or some of the other cations fall into this area by dustfall, calcium, the sphagnum wants it right away. And so it's going to grab onto those nutrients, hold on to them, and of course it's got to balance things out, so it sheds hydrogen ions. Hydrogen ions, yeah.
So, like, are we talking Hindenburg?
Yeah, well, this whole thing could float, yes.
So what that hydrogen then makes the soil more acidic.
More acidic.
Makes
so
the water really acidic.
we think about some of your acids, right? Hydrogen peroxide, hydrogen chloride, hydrochloric acid, hydrogen sulfide, all these
Coke,
acids.
Pepsi,
Yeah, right.
root beers. I mean, I think Coke and Pepsi are about 2.7, 2.8 on the pH scale. Root beer is about 3, 3.2, 3.5. What's this soil?
Probably around 4. So it's probably around 4. So if you recall from your basic soil chemistry that pH of 7 is neutral.
Yeah.
And so a pH of 6 would be
Slightly
10
acidic.
times more acidic, right? And so each pH being a logarithmic scale, so 6 is 10 times more, so 5 is 100 times more, and so this is about 1,000 times more acidic than a neutral piece of ground.
But still not as acidic as Coke.
Yeah. So your teeth would last a little longer in here than they will in a can of Coke.
If we were eating sphagnum.
Yeah.
Okay, so that explains how we have a high level of moisture and a low level of fertility, because that pH, as low as it is, means that a lot of other things are not available, either because the sphagnum has picked it up right away, or the pH has changed the cation configuration, if you will, and so other species can't pick that up. So these two species, the tamarack and the black spruce that we see, really compete well under those conditions, and that's why we see them. Other species don't.
So you think about a tolerance, right?
Yeah.
These things are tolerating those tremendously adverse conditions.
But white pine wouldn't. Yeah.
Right.
Sugar maple wouldn't. No, we don't find them here.
Right.
Okay.
Absolutely. Yeah. And so the other thing about the temperature, we talked a little bit about that.
Ah, yes.
Temperature. So sphagnum is a really good insulator. You'll see frost in bogs like this well into June many times. And so cold temperatures, again, is another issue. As you said, you reach down there and you feel, oh, that feels refreshing. Well, remember that in order for the roots to be competitive, that they have to be actively growing. It's an active process of going out and get a nutrient and bringing it back. There's an exchange. It has to physically do some work to get those nutrients. And cold temperatures, it's hard for those roots to do their work. So again, they're struggling against that, the acidity, cold temperatures, and the high water.
These guys, these species, really, on this site, have to deal with quite a lot.
Tough buggers.
Tough buggers. And the other thing, I mean, this isn't trees, but some of the other plants that are on here, the leatherleaf, or the Labrador tea, or the bog rosemary, or the pale laurel that exist on here, typically are evergreens. And so they're retaining these leaves instead of dropping them on an annual basis, because it's easier to hold on to them than it is to reconfigure leaves every spring. Yeah, ericaceous plants. You find those typically on low fertility sites, whether they be a bog or they be a really dry upland.
So if we think about, you know, the ericaceous plants, you see them as you indicated, dry or wet. And so really what we have out here is a physiological desert. These plants are working pretty hard not to extract too much water, to deal with the cold temperatures and deal with those adversities, just like on the upland.
Yeah.
They're dealing with those adversities.
And what's underneath the sphagnum, the peat moss?
So we dug down, how far?
I maybe
about
went
8
6-8 inches just to grab.
Yep. And so at that point you saw some relatively undecomposed, kind of grayish colored. You can still recognize it as peat. As we continue to work our way down, we're going to find a bit more undecomposed material, sphagnum, decomposed sphagnum moss. And the depth of these peatlands is pretty variable. Remember, these are kind of troughs in the sand dunes.
Okay.
And so as we get to the center of them, you can't say definitively that this is deeper without digging down. You know, it could be deeper over there, and there could be a little hummock of a sand dune down below us. But we've cored these before in this area and seen anywhere from 2 feet of peat down to the sand, all the way down beyond 6 feet where my auger quits.
So like somewhere between 2 and 6 feet or more of just solid sphagnum.
Solid sphagnum. And in places, you know, throughout the county, you will core down, and some of these, they've dug 25 feet and still not hit the bottom.
And still sphagnum.
Still sphagnum.
And below that would be more sand?
Yeah, in this area here, the cores that we've dug up, it has been sand. And it's a kind of an interesting sand because it's the same beach sand. You know,
Sure.
It's that sand like you would see on the beach, blown sand. But down here, it's kind of a bluish gray color. And the bluish gray color is simply a result of that reduction process, like rusting, except bluish gray. In a condition where it's lacking oxygen.
So an anaerobic condition.
Anaerobic conditions.
Interesting. So the sand actually picks up that color, or picks up the byproducts of decomposition in an anaerobic.
Yeah, the particles themselves are
cool.
Yeah.
Cool.
Yeah. And so the bog is going to continue to grow. Sphagnum is going to continue to add to the top.
Yeah.
And centers, typically the centers of these bogs are higher.
Okay.
And so sometimes you get to the middle of the bog, and that's the driest part of the bog.
It's domed.
It's domed, and so the edges of the bog tend to be a bit wetter, and we call those the lag areas, where the water is coming both from the bog and it's coming from the upland. And that's where the accumulation
Both
occurs.
of them pouring and water accumulating there.
Yeah. So if you can make it past the first 100 feet on some of these, you all get out in the middle, and it's pretty good.
You could enjoy it.
Life is pretty good.
All right. Well, we're out here today just in hiking boots because we haven't had a whole lot of rain this summer. There's still moisture just about, you know, in the sphagnum, about 6 inches below, but the rest of it is dry. We don't usually think of bogs burning, but in terms of stand replacement, either the black spruce get old enough to die off and younger black spruce come up to replace them, or this whole area would burn off. And how long does black spruce live?
100 maybe, you know, kind of for a stand, maybe 200 on a good condition.
So somewhere between 100 and 225, maybe 250 at the outset.
Yeah.
So just about every black spruce bog you see, the trees above are at least, you know, somewhere between, if they're at their oldest, 100 to 225 years old or so. And replacement activity is either dying and replaced by whatever young ones are in the understory or fire. Kind of an interesting place. I don't think the bog's burning, but they can't.
And they're competitive out here because of their ability to shade. So if you're on top of the place, it takes a replacement.
Event. Yeah. Or an overstory die-off as a result of age to create the sunlight that allows those younger ones to come up and recruit. All right. Thank you, Brad.
Thank you, Andy.
Pleasure.
Enjoyed it.
Cool.